Hey everyone, and welcome. Today we're going deep, really deep into the world of Carl Friedrich Gauss
Gauss.
and his work that changed, well, something you might not expect, basic arithmetic. Yeah, we're talking about the mind who made playing with numbers cool.
What's so fascinating is that Gauss didn't just, solve math problems. He changed the way we think about numbers, period.
Oh, I like that.
His book, Disquisitiones Arithmeticae, published back in 1801, it's basically like the Bible of number theory.
Okay, Disquisitiones Arithmeticae. That sounds pretty intense. Was this book like an instant hit, or did it take some time for people to kind of catch on to Gauss's genius?
That's a great question, and it's funny you should ask that. For about 2 decades, it was like this hidden treasure, almost too complex, really, for most mathematicians to grasp. It was so dense, so packed with groundbreaking ideas that it took a very specific, very special kind of mind to unlock its secrets.
So who were those brave souls, those pioneers who were able to kind of crack the code of Gauss's masterpiece and bring his ideas to light?
Well, mathematicians like Jacobi and Dirichlet were absolutely key. Think of them like these intrepid explorers who ventured into Gauss's dense mathematical jungle
I love that analogy.
and came back with maps for the rest of us. They took these incredibly complex concepts and made them, well, accessible, sparking really a whole revolution in number theory.
Okay, so what were some of those revolutionary ideas that were hidden in this uh, Disquisitiones Arithmeticae? I'm ready to have my mind blown.
Well, right off the bat, in the very first section, Gauss introduces this concept of congruences. And guess what? You're already using this idea in everyday life.
No way. I am. Tell me more.
Absolutely. Imagine you're looking at a clock, right? It's 1 p.m., but on a 24-hour clock, it's 1300. They both represent the same point in time, just expressed in different ways. That, my friend, is congruence in action.
Whoa.
It's like saying two things are the same, even though they might appear different.
I never thought about it like that, but that makes total sense. So Gauss took something we do every single day and turned it into this powerful mathematical idea. That's really neat.
Exactly. And that's just the tip of the iceberg. Disquisitiones Arithmeticae is packed with these groundbreaking ideas. One of the big ones is his work on quadratic forms.
Okay, quadratic forms. Now that sounds a bit intimidating. Can you break that down for us, those of us who are not math whizzes?
Sure. Imagine you're trying to solve equations, but these equations involve these squared terms. Things like x sot plus y, or maybe 3x sots minus 2 by psi plus 4u.
Okay, I'm vaguely remembering those from like high school algebra.
Exactly.
Yeah.
What Gauss did was go beyond just solving them. He looked at the forms themselves as objects with their own fascinating, unique properties.
So instead of just using a hammer to build something, he decided to like take the hammer apart and see how it works.
Precisely. He was all about understanding the underlying structure,
I like his style.
the relationships, the core principles. He even categorized these forms based on their unique properties, almost like sorting them by their shape, their size, and their color. It's like creating this beautifully organized system
I love,
out of what seemed like random mathematical expressions.
but I got to ask, how does all this, high-level math stuff actually connect to the real world? Really?
Imagine trying to find, I don't know, the most efficient way to pack oranges into a box.
Interesting.
That's a problem where understanding quadratic forms can be surprisingly helpful. They help us understand the relationships between the shapes and the spaces involved.
So thanks to Gauss and his fascination with quadratic forms, we can pack oranges more efficiently.
You got it.
I mean, I can definitely get behind that.
It's like he found this hidden mathematical code behind everyday objects and everyday
I
actions.
really like that.
And he didn't stop there. He also uncovered something called the Quadratic Reciprocity law. And this law reveals this hidden, almost magical relationship between prime numbers.
Prime numbers. They're like the building blocks of all numbers, right?
Exactly.
What's so special about this law? What did he find?
It's like finding a secret handshake between prime numbers.
Oh, I like that.
The law shows us this intricate dance between primes, and understanding this dance can unlock, well, even deeper mathematical secrets.
Okay, you've officially piqued my curiosity.
Uh,
Tell me more about this prime number dance.
well, even Gauss himself struggled to find a complete proof for this law. It took him years of intense thought and calculation, which just goes to show how deep this concept goes. But once he cracked the code, it opened up this whole new way of understanding those fundamental building blocks of numbers, the primes.
It's like he found the Rosetta Stone for prime numbers. I'm sensing a theme here.
Yeah.
Gauss seems to be all about finding these hidden connections, these patterns in the world of numbers.
Absolutely. He had this incredible ability to see the bigger picture, to connect these seemingly disparate, these seemingly separate ideas.
Yeah.
And that's what makes his work so profound, so influential. It's like he gave us this new set of lenses through which to view the whole world of mathematics.
Yeah.
And we're still discovering new things through those lenses today.
This is all so fascinating. We've just scratched the surface of Disquisitiones Arithmeticae, and we've already uncovered congruences, quadratic forms, and this secret handshake between prime numbers.
Right.
There's got to be more.
And there's still so much more to explore.
Okay, I am officially hooked. Let's dive even deeper into Gauss's world and see what other mathematical treasures we can uncover.
Okay, so we've established that Gauss's Disquisitiones Arithmeticae is basically a mathematical treasure chest. And we've opened it up a bit and found some pretty amazing gems,
Right.
congruences, quadratic forms, and that secret prime number handshake. What other kind of wonders await us in this book?
Let's talk about something you might not expect to find in a number theory book.
Okay.
Circles. Specifically, dividing a circle into equal parts using only a straight edge and compass. Wait, circles? That sounds a lot more like geometry than number theory. How did Gauss connect those two seemingly very different worlds?
That's what's so remarkable about Gauss. He saw these connections that other mathematicians just missed.
Yeah.
For centuries, mathematicians had been fascinated by this challenge, right? Dividing a circle into equal parts, but using only a straight edge and compass.
Right.
They could do it for some numbers, but others, especially prime numbers, just remain a mystery.
Yeah, I'm picturing myself trying to cut a pizza into exactly 7 equal slices using only a ruler and a compass.
Right.
It just sounds like a recipe for disaster.
You're not wrong. It stumped some of the greatest minds for a very long time, but then Gauss came along at just 19 years old and proved this mind-blowing theorem. You can construct a regular polygon with a prime number of sides using only a straight edge and compass if and only if that prime number is of this very specific form, 2 to the power of 2 to the n plus 1.
Yeah. Okay, hold on. So you're telling me that the divisibility of a circle, like a geometry problem, hinges on the properties of prime numbers. That's a plot twist I did not see coming.
It's a beautiful example, really, of how these different areas of math can be interconnected, often in very surprising ways.
Yeah.
And this discovery, this wasn't just some cool mathematical trick. It opened up a whole new area of research called cyclotomy.
Cyclotomy sounds intense.
It essentially means circle cutting in Greek.
Okay.
It's a study of dividing a circle into equal parts and all the fascinating algebra that goes with it.
So Gauss, being the genius that he was, he didn't just solve this problem. He opened up this whole new field of mathematics.
He did.
This is starting to feel like a superhero origin story, you know. Young Gauss, armed with his mathematical superpowers, conquers the problem of dividing the circle and then, unleashes this awesome power of cyclotomy upon the world.
I like that analogy.
Yeah.
And the story doesn't end there. Gauss's work on cyclotomy revealed these even deeper connections between number theory and other areas of math, like analysis and algebra. It's like he found this hidden doorway that connected all these different rooms in this vast mansion of mathematics.
So Gauss wasn't just a brilliant mathematician. He was like this mathematical explorer, forging these new paths and revealing these hidden connections between these seemingly separate worlds.
I like that. Yeah.
And all of this came from his work on Disquisitiones Arithmeticae, this book that's still influencing mathematicians, literally centuries later.
It's true. His book was like this seed that grew into this mighty mathematical tree with branches reaching into all sorts of unexpected places.
Okay, so we've got congruences, quadratic forms, the division of the circle, now cyclotomy. Is there anything else hiding in this treasure trove of a book that we should unearth?
Oh, there's so much more. But we can't wrap up this exploration without talking about Gauss's work on these higher reciprocity laws. And yes, this takes us back to those enigmatic prime numbers. Remember that secret handshake we talked about earlier?
How could I forget? It's not every day you learn about a secret prime number handshake. So what did Gauss uncover about this mathematical, I guess, secret society?
He believed that there were even more complex relationships between prime numbers just waiting to be discovered. These deeper layers to the secret handshake. He called them higher reciprocity laws.
Higher reciprocity laws.
Imagine trying to decipher this this even more intricate code, one that governs these interactions of prime numbers on a whole new level.
It's like there's this whole universe hidden within the world of prime numbers, and Gauss was trying to map its constellations.
Yeah.
Did he manage to crack this higher level code?
That's where the mystery deepens.
Yeah.
Gauss never actually published his findings on these higher reciprocity laws. Some historians believe he wasn't fully satisfied with his proofs, while others think he simply moved on to other areas of research that captivated his insatiable curiosity.
The frustration of an unfinished masterpiece.
Right.
But even though he didn't, officially publish, did his ideas on these higher reciprocity laws still influence other mathematicians?
Oh, absolutely. Other mathematicians like Jacobi, Eisenstein, and Kummer, they were fascinated by Gauss's, these little hints about these higher laws. They dedicated years of their lives to deciphering Gauss's clues and building upon his work, making incredible breakthroughs in number theory.
It's like Gauss left behind a trail of mathematical breadcrumbs.
I like that.
And these other mathematicians just followed the trail, making their own amazing discoveries along the way.
It's a great analogy, and it really underscores how influential a single brilliant mind can be, even centuries after their time.
It's amazing.
Gauss's Disquisitiones Arithmeticae, it wasn't just a book, it was like this spark that ignited this fire of mathematical exploration. That's still burning bright today.
It's really mind-boggling to think that one book could have such a profound and lasting impact.
Yeah.
I'm starting to feel like I need a degree in mathematics just to fully appreciate the scope of Gauss's genius.
You don't need a degree.
Wow.
Just a sense of wonder and a willingness to dive into this fascinating world of numbers.
Well, my sense of wonder is definitely peaked.
Wow.
We've talked about congruences, quadratic forms, the division of the circle, cyclotomy, and now these mysterious higher reciprocity laws. It feels like we've only just begun to explore the depths of Gauss's legacy.
And we're not done yet.
Oh, there's more.
There's one final piece of the puzzle we need to explore.
Okay.
How Gauss's work, which seems so abstract, so theoretical, actually shaped the world we live in today.
Okay, now that's what I'm really curious about. Let's bridge the gap between, the world of pure mathematics and the real world applications of Gauss's genius.
That's exactly what we'll do in our final segment. Get ready for some surprising connections.
Okay, so we've gone on this incredible journey through the mind-bending world of Disquisitiones Arithmeticae. We've uncovered, these hidden connections between prime numbers, circles, even packing oranges, right? But now for the big reveal. How did all this theoretical wizardry actually translate into, real-world impact? Did Gauss's work ever leave, the ivory tower of academia?
It did, and in ways you might not expect. While Gauss, he was this theoretical mathematician at heart, his ideas ended up having a really profound impact on fields ranging from astronomy to, believe it or not, the way we shop online.
Okay, now I'm really intrigued. I mean, we've been talking about, these secret prime number handshakes, the mathematics of dividing circles. How does any of that connect to something like online shopping?
Well, let's start with something a little bit closer to Gauss's own interest, astronomy. He was just fascinated by these celestial objects, and his work on calculating the orbits of planets and comets was just groundbreaking. Even today, astronomers use his methods to track asteroids, understand the movements of celestial bodies.
So if we ever need to, dodge a rogue asteroid headed for Earth, we can thank Gauss for giving us the tools to predict its path.
You got it.
That's really putting those theoretical calculations to good use.
Exactly. His work helps us navigate this vastness of space, which is crucial for space exploration, understanding our place in the cosmos.
For sure.
But let's zoom back down to Earth for a moment.
Okay.
You mentioned online shopping, right?
Yeah.
Well, every time you make a purchase online, you're relying on something called error-correcting codes.
Error-correcting codes.
To ensure that your information is transmitted securely.
Are you telling me that my credit card details are protected by some mathematical wizardry dreamed up by Gauss?
You got it. These codes are based on these principles of number theory and algebra that Gauss helped develop. They ensure that data can be transmitted, stored reliably, even if there's, interference or noise.
Yeah.
It's like having this mathematical safety net that catches mistakes and keeps information intact.
So those abstract mathematical concepts that we've been talking about are actually working behind the scenes to protect my my online shopping sprees.
Precisely.
That's pretty amazing. What about other applications? Did Gauss's work have an impact beyond, astronomy and data security?
Oh, absolutely. One of the most significant areas is cryptography. The art of secret codes. Modern encryption methods, the ones that keep our online communications, our transactions secure, rely heavily on number theory, particularly prime numbers.
Okay.
Remember that secret prime number handshake?
Oh, yeah.
It turns out that the principles behind that handshake form the basis of many encryption algorithms that are used today.
So every time I send a confidential email or make an online payment, I'm unknowingly relying on the work of a mathematician who was obsessed with prime numbers.
Yeah, you could say that.
It's like he's secretly protecting my digital life.
His work laid the foundation for this the secure communication, the data transfer that's just essential for a digital world. It's another example of how these seemingly abstract mathematical ideas can have this huge impact on the way we live, work, and interact with the world.
This has been an incredible journey. We started with this dense, complex book published over 200 years ago, and we've ended up exploring the cosmos, deciphering secret codes, and even securing our online shopping carts.
It really is remarkable.
It's a testament to the enduring power of Gauss's work and the surprising ways that pure mathematics can shape our lives.
It's a reminder that the pursuit of knowledge, or even in the most abstract realms, can lead to these really practical breakthroughs that benefit all of humanity.
Yep.
And that's the beauty of science and mathematics. They have this power to connect us to the universe and to each other in these unexpected and profound ways.
Well said. I think we've all learned a lot about Carl Friedrich Gauss, the prince of mathematicians, and his enduring legacy.
He truly was a remarkable mind.
Absolutely.
And his contributions to mathematics continue to inspire and amaze us.
And on that note, we come to the end of our deep dive into the world of Gauss. We hope you've enjoyed this journey and that you'll continue to explore this fascinating world of numbers.
Until next time, keep those minds curious, and remember, the world of mathematics is full of wonders just waiting to be discovered.